guys, good morning. This is week is it? I think week 12. Okay? And we've already started the topics of forces. Okay? So last week we looked at different kind of forces, contact forces, non-contact forces. We looked, I think I'm just going to put on the lights. So just pause here for a second. Put lights on. Yes, I think that's a bit better. So we looked at different types of forces, and then we drew a forces diagram on different kind of, in different scenarios. We already also had one lesson where we start looking at gravity in a little bit more focused. So our next couple lessons, we're going to carry on with gravity, okay? And what we noticed in the last lesson, that weight and mass are not the same thing, right? Mass is a property of an object, okay? So I have a mass. It's basically how much stuff I'm made of. Okay? Everything is made out of these particles we call atoms. So it's basically how many atoms there are and how big these atoms, okay? But weight is actually a force. So your weight is the force that pulls you downward. We call it gravity, okay? Now, so we realize that these mass and weights are not the same thing, but obviously they are related to each other, okay? The more mass an object has, the more gravity pulls it down, the higher the weight, okay? So in this lesson, if you were in the classroom, you will do a practical, okay? And what you will do is you'll take different masses, okay? And weigh them using a force meter, okay? So we're going to have to do it at some point when you come back. But for now, I want you to take the opportunity and work a little bit on our graph skills. So I've got some results, made up results, okay, that I've done for you. So you've got mass of 6 different objects. Okay, let's say we take a 1 kilogram, 2, 3, 4, 5, 6 kilogram masses, and we weigh them. We measure the weight, the force that pulls them downward. Okay, so I've got 9, 20, 29, 42, 51, and 61. I hope you guys can see that. Okay, what I'd like you to do now is at some point just pause me, copy this table, and then draw a graph, okay? What kind of graph? What do we have in the graph, right? In any test, there will be a test when you guys come back, okay? Okay? And I'm pretty sure there will be a graph question there. Graph questions are usually 6 marks, okay? And the marks you get are for the following. First is the title. You need to write a title. And remember, title is always going to have verses in the middle, and you have the independent dependent variable. In this case, it's the mass. So I would write weight versus mass. If you write mass versus weight, it's fine. Okay? I think it's better to write the dependent variable first. Remember, this is the dependent variable, the one on the right, independent on the left. So write weight versus mass. Okay, so that's 1 mark. Second mark, 2 marks actually are given for labeling the axes, including units. So your horizontal axis is always going to be the independent variable, in this case mass, okay? With the unit in brackets kilogram. The dependent variable will be here, okay, weight in Newton. So if you've done 1, 2, 3, you got already 3 marks out of 6, and you can agree with me that take no time. Okay? The tricky thing with graphs is that they do take quite a long time, okay? But the first 3 marks out of 6 take less than a minute. So do them. Don't leave them till the end. It's always sad for me to see students that did all the plots and forgot to label the axes. Okay. The next thing is to find out a scale. Okay. Now a scale for the mass is easy. Okay. It simply goes up by 1 every time. So that's not problem. 1, 2, 3, 4, 5, and 6. Okay. To get the scale for the y-axis often is a bit more difficult because they won't necessarily go in the same steps. Okay? But here it also is pretty similar. You can see the maximum you get to is 61, and it goes by about by 10 units every time. So it probably makes sense to have 20, 30, 40, 50, 60 or enough space here. As long as you've got enough space to get to 61. Okay? You got to make sure you know where to put, for example, 9. Okay, so you don't, obviously you guys are going to have to use the line paper, that graph paper. I will put a graph paper onto OneNote. If you've got a printer, that's probably the best, then just print that. Okay, if you don't have a printer, what you can do, that's probably the best thing to do is, yes, you can just do it on OneNote. So I will put the graph paper on OneNote. You just go to draw, click on draw, okay? On OneNote, you got a place that says draw, and then you can pick up a pencil, okay? And then just put little points. So you can actually do it on the graph paper. You can write down the title, the scale. You can put the scale. You can put the dot, and even draw a line. Everything on OneNote without actually drawing it on paper. Okay, but if you do have a printer, I know most of you don't, but if you do it, that's better because then you're using your pencil, you're practicing more real kind of realistic scenario. Okay, and then we draw it. Okay, so at this point, yeah, just pause me now, I think, and draw the line best fit. Yeah, just pause me now. I'll wait. Won't go away. Take your time. Okay, this lesson is really mainly about drawing a graph. Okay. So hopefully you drew the graph, and I'm just going to show you a bunch of, what my graph would look like. So I'm going to say, okay, 1 is 9. Obviously, I don't have a graph paper here, so it's not very accurate, but yours should be accurate with all the squares. 2 is 20. 3 is 29, which is like here. 4 is 42, which is there. 5 is 51, which is about here. And 6 is 61, which is here. Okay? So after you drew the plots, okay, and remember plots must be drawn in crosses, not in circles, not in dots, blobs. It needs to be in small little crosses. Okay? Then comes the point of a line best fit. Now a line best fit can either be a curve up, curve down, okay, or straight line going up, or straight line going down. Okay? That's as far as line best fit is concerned. We don't do zigzag, we don't do dot to dot, we don't do little wavy things, okay? Line does not have to go through all the points. In fact, a lot of the time it doesn't go through any of the point at all, okay? Just going to grab a ruler, okay? So how do I do that? It's best work, okay, if you have a transparent ruler, okay? Because then you can see the point. And you just arrange the ruler in a place where you can see some of the points above, some below. We call it an even scatter. You want to have an even scatter of plots. Okay? So I'll put it about here. This is going to be a bit more difficult here on paper. But you can see, okay, didn't do the best job. So I've got 2 points above, pretty much, 3 points below, 1 is spot on. In hindsight, I probably should have drawn the line best fit a little bit below so I can have 3 and 3, but or maybe turn it, rotate it slightly. But if you make, there's 2 people will never draw the same line best fit. In fact, the same person is not going to draw the same line best fit if you do it twice. Okay, there's always room for errors. Okay, but if it's blatant, far away from the points, or 1 point below and like 5 points above, then that's not going to get the mark. Okay. So that was the 6th mark, okay, I didn't mention. So 1, 2, 3 for the label. The 4th mark usually goes for, to make sure that the scale is correct. You can't go, a common mistake I see people do is, they go, okay, 9, 20, 29, 42, 51. Obviously that's wrong, because it's not going in the same steps, okay? We don't have a constant scale, okay? So that's the 4th mark. The 5th mark is to check the points. I'm checking that you plotted correctly. And the 6th mark for line best fit. Okay? So, just looking at this line best fit, what can we conclude? What can we conclude? We can find a relationship between the weight and the mass. Okay? We can find a relationship between the weight and the mass. And if you take a point here, take a point on your own graph, okay? On the graph, not the plot, the graph itself, okay? And what you can find out is that if you want to go from the mass to the weight, what you're basically doing, you're timing by 10, okay? So the results, when you look here, are not 100% clear because we're always going to have a little bit of error. But if we draw the line best fit, okay, we get rid of that noisy errors, then we can see that 2 kilogram is pretty much 20 Newton. 3 kilogram is pretty much 40 Newton. So if you want to know the weight of an object, all you got to do is really time it by 10. Okay? And we're going to discuss this in our next lesson. Here we go.